Hey everyone, Mr. Newman here, and today we're going to learn about the Unit 4 Test Study Guide. On this, I'm going to go over this slowly, and I've also made this video skippable, which means you can skip and fast forward to the parts where you need the most help. Notice the tabs say which question numbers are there, and so please watch and listen carefully to any questions that you are unsure of how to do. And you can skip and fast forward to the answers and just to make sure you get it right. So let's get started. For the first one, we want to simplify 7ab squared times 3a to the fifth b cubed. This is just a monomial times a monomial, so I'm not going to distribute anything. We just need to multiply the coefficients, 7 times 3 is 21, and multiply each of the exponents, each of the powers. When you multiply powers, you add the exponents. So that's an invisible 1 on the a because it's a to the first. And 1 plus 5 is 6, so a to the sixth. For b squared plus b times b cubed, you're going to add the exponents, so you get b to the fifth, and that is your answer. For number 2, it says find the area of a rectangle with length 5qr cubed and width 4q to the fourth r to the fifth. Area is length times width, so I'm going to take those two monomials and multiply them together, which means that this problem is very similar to the first one that we did. Let me write them out. We have length and we have width, so let's write that out. Area is 5qr cubed times 4q to the fourth r to the fifth. When we multiply those out, 5 times 4 is 20. Q times q to the fourth is q to the fifth. R cubed times r to the fifth is r to the eighth, and that is our answer. Now, for number 3, if we're given that polynomial, what is the degree of the function? Well, degree is the largest exponent. Looking there, I have an exponent of 2, 4, and 5. The biggest one is 5, so the degree is 5. For number 4, suppose we have that polynomial. What is the coefficient of the quadratic term? You need to know two things here. You first need to know what the word coefficient means, and then you need to know what the quadratic term means. The coefficient is simply the number in front. In other words, the number multiplied by a variable or the number in front of a variable. The quadratic term, well, there are three terms here. The term is any group of numbers and variables that are separated by addition or subtraction. And the quadratic term is the term that has a variable squared on it. So see how r squared is quadratic? That means the coefficient is -5. You have to include the negative. That's very important. Another important thing is notice that I don't include the variable. -5r squared is not the coefficient, just the -5. For number 5, we're going to simplify this, and you have to remember that anything squared means that thing times itself. So I first want to write out m minus 8 times m minus 8. Two binomials multiplied by each other. Then I'm going to distribute the m minus 8 to both the m and the -8, and we get that. Then I want to distribute the m. We get m squared. M times -8 is -8m. And then distribute the -8. -8 times m is -8m. And -8 times -8 is positive 64. Don't forget to keep the negative with the 8 as you multiply it. And a negative times a negative is a positive. Lastly, we need to combine like terms, so we get that m squared minus 16m plus 64. For number 6 through 9, it just says simplify the following expressions. This could be adding, subtracting, multiplying, distributing, or any combination thereof. So for the first one, we're simply adding, and that means we just need to drop the parentheses and combine like terms, since it's addition. So let's drop the parentheses and then combine like terms. Like terms are any terms with the same variable and same exponents on that variable. So for example, a squared and -5a squared, those are like terms. If you are used to adding coefficients, you can treat the a squared as being 1a squared, and that would help. 1 plus negative 5. 2a and 6a are like terms. So what I like to do also is I like to check off each one as I count them. That way I make sure to get all of them. It organizes my work a little bit. So 4a cubed, that's the largest term. If we're writing it in standard form, we want to write the largest exponent first. Then negative 4a squared is the result of adding a squared and negative 5a squared. Check those off. Add 6a and 2a becomes 8a. And lastly, the negative 3 is all by itself. So I'm going to write down negative 3 and check that off. And there's my answer. For number 7, we have subtraction. The thing you have to remember here is that there's a negative 1, and you need to distribute that negative across all the terms inside the second set of parentheses. So let's drop the parentheses for the first one. And for the second one, we're going to distribute the negative 1. So we get negative 5e squared minus 4e minus 3. Let's now combine like terms. 7e squared minus 5e squared gives us 2e squared. The negative 4e is all by itself, so I'm going to check that one off. And then negative 6 minus 3 gives us negative 9. And there's our answer. For number 8, I want to distribute that 2c. 2c times 3c is 6c squared. 2c times negative 4 is negative 8c. And I'm just going to tack on that plus 5c squared. Then we want to combine like terms. So 6c squared and 5c squared becomes 11c squared. Check those off. And I just write minus 8c to make sure I get all the terms. And there's my answer. For number 9, we're going to multiply or distribute the binomial first. 9d plus 8, and it gets multiplied with the 7d, and that is what you get. Then that 9d plus 8 will be multiplied by the 6, so we get plus 6 times 9d plus 8. If we multiply 7d and 9d, we get 63d squared. Distribute the 7d all the way across. Then distribute the 6. Combine like terms. And we get 63d squared, 110d plus 48. And that's our answer. For the next section, the key word here is the word just. We want to factor just using the greatest common factor. This threw some people off already. So the biggest number that goes into 9x squared and 36x and negative 27 is 9. So I'm going to factor a 9 out. That means I'm going to divide that 9 out of each of the terms. Inside the parentheses, we get x squared plus 4x minus 3. And that's all we're going to do. Just factor out the GCF. There's no variable on the negative 3, so there's nothing else that we can factor out of those 3 terms. And then we're done. For number 11, you have to be very careful because all 3 terms have a variable. So we factor out the 5 because the 5 goes in all 3 terms, but we also factor out the x. And what's left over? Well, when you divide out a 5x from each of these, you get x squared plus 2x minus 4. And now we're done with that one. For number 12 and 13, they say factor using difference of squares. You can use product sum here, but I'm going to show you how to do difference of squares because it's a nice little shortcut. First of all, for difference of squares to work, you have to have a difference and 2 squares. In other words, you have to have subtraction, and the first and last term, the only 2 terms, must both be perfect squares. Here we have x squared and we have 100, so this definitely works for number 12. And the way you set it up is you put 2 sets of parentheses, one with a positive in the middle and one with a negative. And then you take the square root of the first term. Well, the square root of x squared is x. And you write that in the first term of both binomials. Then you take the square root of the second term, the 100, the square root of 100 is 10. And so you write that in both the second part of both binomials. And we're done. Wasn't that nice? Difference of squares makes factoring much nicer. Here, if you see DT, that stands for double trouble, which means we're going to use difference of squares, and we have to look out. There might be another opportunity for us to use difference of squares. So, let's do the two sets of parentheses, a plus and a minus. The square root of x to the fourth is x squared. I know that because x squared times x squared gives you x to the fourth. And the square root of 81 is 9. So we're done. Oh, we're not done though. That's why the double trouble, the dt, is there. X squared minus 9 is still two sets of perfect squares. It's a difference of squares. That's what DOS stands for. So let's rewrite x squared plus 9. We have to have that down. And let's think about, okay, what are the two perfect squares? Well, it's x squared is a perfect square, and 9 is a perfect square. So the square root of x squared is x, and the square root of 9 is 3. So we write x plus 3 times x minus 3. And now we're done. For number 14, we're going to factor using sum and product, or product sum method. We write P and S. That's the way I taught you. When you do that, remember product is the first coefficient, the leading coefficient, multiplied by the constant. In other words, A times C. Here A is 3, C is negative 6, so A times C gives you negative 18. The sum is 7. So we're thinking of what numbers multiply to get you negative 18 and add to get you 7. Well, you can always start off with 1 and negative 18 and negative 1 and 18. Then I'm going to try 2. Negative 18 divided by 2 is negative 9. And we can also switch them, negative 2 and 9. Keep in mind that they need to add up to 7. So here, negative 2 and 9 are the two numbers that add up to 7. Sum to 7. So that's how I'm going to split up 7x. 3x squared minus 2x plus 9x minus 6. Then we find the greatest common factor of the first two. That would be x. And 3x minus 2 is what's left behind. And then we're going to find the greatest common factor of the second two. That's 3, and 3x minus 2 is left behind. This is good because, remember, these must be the same when you're using the sum and product method. And they are here. So we can take this last step. We know that 3x minus 2 is one of the factors, and x plus 3 is the other factor. And there's our answer. For number 15, let's use product sum again. 1 is the coefficient as the a term. It's the coefficient of the x squared term. And negative 1 is the coefficient of the linear term. In other words, that's b. So 1 times negative 2 is negative 2. That's our product. The sum is actually negative 1. And the two numbers that multiply to get you negative 2 and add to get you negative 1 are negative 2 and 1. That's how we're going to split up negative x then. And we get, when we find the GCF of the first two, that's x. The GCF of the second two is 1. So we get x minus 2 and x plus 1. That's our answer. For each of these, in fact, this whole page of factoring, you can always check your answer by taking your answer and multiplying it back out. That might be a good idea, especially if you find yourself with some extra time at the end of the test. Next, factor using multiple methods. Usually this requires you to find a GCF first. So let's check for the GCF. Aha! 4 goes into all three of those. 2 also goes into all three of them, but it's not the greatest common factor. So 4 is the number we want to divide out. When you divide out of 4, you're left with 3x squared minus x minus 4. Now we're going to use product sum on the inside. That was GCF first. Now product sum on the inside. So we have 3 times negative 4. A times C is negative 12. That's our product. And the sum is negative 1. What multiplies to negative 12 and adds to negative 1, we get negative 4 and positive 3. So we split negative x into negative 4x and positive 3x. Then I'm going to rewrite and factor out the GCF of the first two. That's x times 3x minus 4. The GCF of the last two is just 1. So Fortunately, that makes both of our factors be 3x minus 4, 3x minus 4, and that's what we want, which means our final answer is 4 times x plus 1 times 3x minus 4. That's our answer. For number 17, we want to check GCF first, and we see that 2 can be factored out. And this is good because if you notice, what's left over are 2 perfect squares. So we can finish with the difference of squares. You might say, this looks different than the difference of squares we did before. Well, a little bit, but let's just follow the same procedure and you'll see we'll get a quick answer. So, have the 2 out in front, and the difference of squares here, we're going to put 2 sets of parentheses, one with a plus and one with a minus. The square root of 25x squared is 5x squared because the square root of 25 is 5 and the square root of x squared is x. So I'm going to write 5x and 5x in both of the first terms. Then the square root of 1 is 1, so I'm going to write a 1 in both spots. And we're done. Difference of squares really simplifies the process, so that's why it's important to look out for that. In the next section, find the roots of the following equations by fully factoring. Roots is another word for solutions, which is another word for x-intercepts, which is another word for zeros. Any of those all mean the same, so let's find it. That's when you have an equation and it's equal to 0. Sometimes you have to set it equal to 0. Here, we already did that. So, step 1, check, we're good. Next, step 2 on these kinds of problems is always to factor. So let's factor using product sum. The product is going to be 1 times negative 6, while the sum is going to be that negative 1 in the middle. What multiplies to negative 6 and adds to negative 1? Well, negative 3 and positive 2, of course. So let's split up negative 1 into negative 3x and positive 2x. GCF the first 2, GCF the last 2. And you get x plus 2 times x minus 3 equals 0. That's step 2. That's the factoring bit. Step 3 are the baby equations. So I'm going to set each factor equal to 0. There's one factor. There's the other factor. X plus 2 equals 0. And x minus 3 equals 0. Some people skip this step, but it really trips them up if anything is a little bit different. So make sure you write out that step. When you subtract 2 from both sides, you get x equals negative 2. When you add 3 to both sides of the second equation, you get x equals 3, and there's our 2 solutions. X equals negative 2, and x equals 3.